Well, student, now I will be telling you something more about Doppler effect. I derived expression n dash equal to n bracket c plus vm minus vo upon c plus vm minus vs, taking all moving the same direction. Now suppose, case 1, suppose number 1, source moves away. Source moves away from stationary observer. Then you don't need to put here only. Okay? We know this thing. No, I will be telling you here how to obtain. While medium at rest, if you are asked like this, here is the observer at rest, VO0, and source is going away as with speed Vs. So sound is supposed to move this way. Velocity of sound C is this. So here velocity of sound with respect to moving source, C dash will be C minus C plus Vs. When you are moving opposite to any moving object, the velocity get added. Suppose you are sitting in one train and other train come on parallel track. You feel that other train was moving faster, while it may mean that your train is faster, because you are measuring the speed of the other train with respect to you. So your velocity get added to that velocity. So when wavelength frequency changes, sound changes, speed to lambda dash c by c dash by n, yani is equal to c plus vs upon n. Now this wavelength is being received by observer. तो क्या होगा, hence and the speed of sound with respect to the stationary source. वो तो C ही रहेगा, and therefore apparent or observed frequency n dash equal to c upon lambda dash, and you know here it is c upon c plus vm upon n. So that way here n dash come out to be n bracket c upon c plus vm. As numerator is less than denominator, so n dash is less than n. So that way you can obtain for anyone. Now number 2. If observer moves towards stationary source, number 2, observer moves towards stationary source while medium is at rest. In here it is source as Vs0, and it is observer moving VO. So see it always this way. Whereas sound with rest, direction whereas sound is taken from source to observer. So here by source at rest, medium at rest, so velocity of sound with respect to stationary source equal to C, so lambda equal to C by N. Now wavelength will not change, बस पहले क्योंकि C में change हो गया था. Now these wavelengths are received. Wavelength, the sound wavelength lambda is approaching the observer. So velocity of sound with respect to moving observer. C dash now it will be C plus VO, and hence frequency and dash equal to C dash upon lambda. Indicators and dash equal to C plus VO upon C by N. So now N dash equal to N bracket C plus V upon C. So it will become higher. The frequency will be higher. I told you earlier that object will depend who moves, the source of the observer. तो जब source of sound move करता है towards stage observer, then n dash was n bracket C upon C minus Vs. It may be that Vs equal to VO, but n dash is different in the cases. So here it is a big factor कि who moves. I hope you have got my point. Now I will give you one example here so that you may understand. There is a question here. With what velocity? Sorry. Yeah, calculate the velocity of observer towards stationary source so that observed frequency is twice the real. Also, find the velocity of source of sound towards stationary observer for same change. जो ऊपर कहा गया है कि ट्वाइस हो जाए वो, तो उसके लिए दोनों केस में करना पड़ेगा। पहले मैंने कहा फाइंड द वेलोसिटी ऑफ ऑब्जर्वर towards stationary source. So when we know here solution like this, when observer move, so n dash equal to n into c minus v upon c. Take here c as, so the c generally taken 330, but I will use as c here. So now n dash should be twice the n. So 2n equal to n c minus v upon c, and 2c equal to c minus vo, or vo is equal to minus c, यानी कि magnitude of velocity observer is equal to the magnitude of velocity sound, but sign opposite means कि sound source this sound going this way, observer coming this way, VO. Here minus sign indicates that VO is opposite to velocity sound. And if source moves, it means observer has to move with the speed of sound towards the stationary source. Now if source moves along, then n dash equal to n c upon c minus bs. So again 2n is equal to n c upon c minus bs. N dash cancel. 2c minus 2bs equal to c minus 2bs minus c. Vs, sorry. So here Vs come out to be c by 2. So if source moves towards the stationary observer with half the speed of sound, then the observer may find the change as twice, but for the same change, observer has to move with the speed of sound. Here see the speed of sound. This is one explanation here. I gave this question here just now, just to understand that in sound, Doppler effect depends who moves, not only on the distance between the two. बस जनरल तो यही है, जनरल बात तो यही है कि अगर डिस्टेंस घट रहा है बिटवीन ऑब्जर्वर और सोर्स ऑफ साउंड तो फ्रीक्वेंसी हायर, but higher frequency will depend who moves. They have to come closer. If source moves alone, if observer moves, if both move with the same, है ना, तो same speed, then frequency of the will be again different, है ना. तो here in sound, Doppler effect depends the fact whoso moves. Now remember here, dear friends, Doppler effect is all these equations are true if velocity of source velocity of observer and medium, and velocity of medium is less than the velocity of sound. यानी कि v लेस देन c, किसी की भी वेलोसिटी हो, वैसे ऑब्जर्वर हो, सोर्स हो, तो वो जब तक c से कम है तो डॉपलर इफेक्ट एप्लीकेबल है. any object or source sound when moving more than the speed of sound that produce the wave whose amplitude keep on increasing, and those sounds whose amplitude source has moved away and amplitude of sound keep on increasing are called supersonics. And those objects moving with the speed of more than speed of sound are also called supersonics. So I told you here everything about Doppler effect in sound. I want to tell you one more question here. If suppose is a source and it is north, south, east, west. Suppose source is moving with velocity Vs in still air with velocity Vs. Then what is the wavelength of sound? If Vs is equal to c by 10, suppose, यानी कि वैल्यू साउंड का 1/10 है, तो what is the wavelength of sound in the east? Source is moving towards east. So what is the wavelength of sound in the east and in the west? For observer in the east, for stationary observer speed of sound with respect to source, वो c plus c minus bs होगा. Therefore lambda dash equal to c upon c minus bs. Here c dash is c by 10, so c upon c minus c by 10. So lambda dash equal to c upon 9 by 10 c. Sorry, 10 minus 1. Oh, sorry. Lambda dash to c by n हो गया, दिमाग खराब हो गया. Sorry बच्चों. Lambda dash c dash upon n यानी कि c minus bs upon n. तो lambda dash equal to c minus c by 10 upon n. So it is 9 by 10 c by n, and it is lambda. So lambda dash equal to 9 upon 10 of lambda. So wavelength will get decreased. If this wavelength had been suppose 90 centimeter, तो 81 centimeter हो जाएगा, फिर कम हो जाएगा. Now for west object, source to going this way. For stationary source in the west, the best of souls. Force here, observer is here. Source so going this way. So velocity of sound with respect to source. C dash equal to C minus Vs. Plus Vs, sorry, plus Vs. And therefore lambda dash equal to C dash upon N indicates C plus Vs upon N, or lambda dash equal to C plus C by 10 upon N, indicate 11C by 10 by N. It is lambda. So lambda dash will be 11 by 10 lambda. So that way wavelength will be higher. So please see the situations. Wavelength of sound changes only when speed of sound with respect to source changes. I will be telling you something more or some more numericals, and in coming video I will be telling you about Doppler effect light. People avoid this because this is not in syllabus. But if you are learning Doppler effect, you should learn each and every aspect of that and effect. Don't go that way because this is not in course. It is the general habit of teachers just to finish the syllabus in a limited time, just by saying that this is simple, this is you have learned in class 11 and 10, and now this is out of syllabus. So that practice here not allowed, because you have to appear for different competitive exam to have a good career. Okay, thank you dear friend. Please like the video, share the video, and ask your friend to subscribe channel. Thank you.